Hello, I'm Mark Lassoff. Welcome. In this video, we're going to create a finger painting application. In creating the application, you're going to learn about HTML5, the specific canvas element of HTML5, and JavaScript. This is a fun little application to do, and will teach you a lot about the HTML5 canvas. If you like these videos, I'd invite you to go ahead and hit the like button. Go ahead and make a comment or subscribe to our channel. Let's get started and take a look at the code. So I've got my application here on the left. You can see the HTML code, and then I've got a browser window where we can test. I'm going to test using the Python simple HTTP server on port 8000. It's always a better practice to test using the server versus loading the application directly into the browser as a file. All right, here we go. So a couple of features. We can choose a color. So I don't know, let's choose like an orange there. We can choose the width of the line we're going to draw, and then we can finger paint. We could choose a different color, and we can finger paint again. And when I'm holding the mouse button down, we're drawing. When the mouse button is not held down, we're not. I can clear my drawing and start over, and this time with a thinner line. Or I can save my drawing simply with a right click to save, and then go back. So those are the features of our application, pretty straightforward. Let's go ahead and take a look at the code. There's actually 3 code files we're going to look at. The HTML code, which is the structure of our application, the JavaScript, which is the interactivity, and then we have a little bit of CSS cascading style sheet code for the actual look and feel of our app. So let's start with the HTML. That makes the most sense. So this is designed to be a mobile app. So there's a couple of things in the first part of the application that relate to that. Since this is HTML, we need a doc type declaration first, indicating what version of HTML we're using. This is HTML5. And then we have our HTML root element, just the beginning of our HTML. Our head section with our metadata. Our character set, which is UTF-8, and then we have our viewport meta tag. This is important to make most mobile applications act more like applications and less like a website when being run on a mobile device. Since we're using HTML and JavaScript, essentially the web application development technologies to make a mobile app, this is necessary. The code is pretty straightforward. We're going to go ahead and use metaname viewport, and then we're going to set that to an initial scale of 1, meaning 100%, a maximum scale of 1, turning off user scalability, which means the pinch gesture won't work. The user won't be able to resize the app with a pinch. And then the width is going to be the width of the device. This is standard code when you're creating an HTML-based mobile app. I'm including the Cordova.js library, so later if we were to deploy this to iOS or Android, we could use Cordova to do so. It doesn't have any effect on anything we're doing right now. The FingerPaint.js library, that's right here. It's not a library. It's actually a code file that I wrote to make this work. And then we have a link to our CSS. Our CSS is very short, just setting the margins on the body to 0, so we go edge to edge. Our default font to Arial. Setting the canvas background color to gray. Creating a little border on the bottom and a margin space on the bottom. And some other things here just really for spacing in our application. All right, so then the body is fairly straightforward. If we look at the app, there's a couple of components. There's the drawing area here, right? And that goes edge to edge. And at the bottom, we've got our color picker, our width slider, and our save and clear buttons. So those are all defined right here. We have our div that contains the actual canvas. We have our image ID canvas image, this right click to save, and this button back. Anybody remember this? This actually comes up when you click the save button, right? That's what this is, but we don't see this until the actual save button is clicked. We have our tools div here, and this contains our color input where the user can select a color. This contains our line width slider where the user can control how wide a line is. Right here, there's our width slider. There's our color chooser. I don't know if that always defaults to the darkest color. There we go, drawing with blue. Our save button and our clear button. Note that any HTML element that needs to be accessed through the JavaScript is given an ID attribute. The value of that ID attribute is exactly how we'll bring these elements into the JavaScript. It's important to remember by default, the HTML and the JavaScript know nothing about each other. So we've got to use an ID in the HTML to link it to the JavaScript. You'll see how that's done in a minute. And that's it for the HTML here. So less than 30 lines of HTML to make this application. And that's because the real heart of the application is in the JavaScript. So we started with two variables that are global. That's why they're defined outside of any function. The first is drawing equals false. Drawing is essentially whether or not the mouse button is pushed and whether or not we're actually going to be drawing as the user moves the mouse. So if we look at the app, drawing is false. I push the mouse button. Drawing is now true. So I release the mouse button and drawing is false again. So that's what that flag on line 1 does. Line 2 is the context, and that essentially wraps around the canvas for the actual drawing. Technically, we use the context to draw or put text or images onto the canvas. So our context also has to be global because it's used by more than one function. Our window.onload function, this runs after all of the HTML is loaded, so that's why we have this window onload event. This waits till all the HTML is loaded and everything is drawn on the screen, and then this function runs. So what this function does is essentially defines the clear button. So if you look document, get element by ID, btn clear, add event listener, click. So that's listening for someone to click the clear button, just like I just did. When that button is clicked, the following function just runs. Context, clear rectangle, 0, 0, to the canvas width and the canvas height. The way we clear the actual drawing canvas is with clear rectangle, and we clear it from the top left corner to the bottom right corner, which is the width and the height, using the XY positions, right? So 0, 0 to the bottom right-hand corner, which is the width and the height. We also define what's going to happen when the back button, or btn back, is clicked. And you remember the btn back button appears right there. And what we're doing when that button is clicked is we're essentially displaying certain divs and hiding others. So the My Canvas div is displayed, the Save Area div is not, and the tools are displayed. So we can turn any of these areas in the HTML on and off. So here is, for example, in the HTML, our tools, right? So we can turn this block on and off. We can turn the save area on and off. And that's what's happening here in the JavaScript when the different buttons are clicked. So these buttons essentially change the states in the application. We go into save state, we go back into drawing state. And that's what this code is doing, is turning these on and off based on someone clicking the back button or the clear button or one of the other buttons. All right, so now we're also going to add actions to the other elements that are here. But remember, all of these actions that we're adding onload don't run until the user does something. So here, this doesn't run until the user clicks on BTN clear, or the user clicks on BTN back. So this is for the line width, right, for this guy. Nothing happens here till the user actually changes this width. So on the line width element, we're adding a listener for a change event. The change event, of course, is different than the click event. The change event runs when the value of the slider changes. So when that changes, we'll run this function. We're going to set the line width on the context, remember that's what we're drawing on, to document get element by ID line width value. So this has a value, and we're going to assign that value to the width of the line we're drawing. So this is as thick as we can draw. Change it again, it assigns the thin value or something in between. So that's what's happening here. The line width is being set. It's a little bit confusing because we're referring to line width twice. First for the listener on line width, right, listening for the change event, and then we're going back and getting the value, which is where is it on here? 0 or 1, 2, 3, 4, 5, 6, whatever this numbering system is. We have a similar thing happening with the color. The color looks at the color change object and listens for a change on that. So here's the color change object. This will change when I select a new color. So I selected a new color, that's changed, and now I can paint in that color, just like that. So when the value here changes, it's obviously going to change the color I'm drawing in. So color change, listening for the change event again. On the context now, which we're drawing on, we're going to change the stroke style to whatever color value we've got here. So we'll change the stroke style to a bright red. So this is now bright red, that's the value here. That changes essentially the stroke style that we're drawing in to this red color here. So we can finger paint. The last action we're going to prepare for here in this series when the actual document loads is the user clicking the Save button. User clicks the Save button, the drawing goes away. That's not quite true. Let's go ahead and put a drawing here. The drawing becomes uneditable and the user's instructed right-click to save. So when the Save button is clicked, first of all, we make the canvas display none. That disappears. The save area, which is this, appears with the instructions, and the tools disappear. So this is all the save area, which has the drawing that we created, the instructions, right-click to save, and our back button. What this code is doing here is when the Save button is clicked, we're getting the canvas and whatever drawing is on it, right? So let's add to my drawing a little bit. So again, when we click the Save button, we're going to retrieve the canvas and the drawing that's on it, and we're essentially going to make it into an image to place right here in Save. So that's what this does. It takes the canvas and it makes it into an image. The toDataURL command is what's doing the heavy lifting here. And then we're going to take that image and we're going to put it inside our Save area. All right, so that takes care of all of the elements of the UI, right? We have our color changer. We're listening for a change event. We have our width. We're listening for a change event. We're listening for a click on Save or Clear. And then we have to take care of the actual drawing action here on our canvas. So again, we're still in the onload function, but this is important. You'll notice that no matter how big the window is when we load the app, that's how big our canvas is. So we want the canvas to be the same size as the application so it covers all of this real estate here, no matter how big someone's window is. You've got to think about this when you're developing apps. People will be using your apps on different sized devices. They might be using it on a small cell phone screen or something as large as a TV screen. So you've got to code your apps to deal with all of those different situations. So that's what's happening here in the size canvas section of our document. We're going to get the context from the canvas and we're going to go 2D, which means we're in 2D mode in the canvas. And then we're going to set the width and the height of the context, canvas.width, so context canvas.width, to the width of the window. We'll set the height of context canvas.height to the height of the window minus 60, giving us room for the tools at the bottom. So this is setting up the canvas to be the same size as the window. Now we also have to handle moving the mouse around, right? Because that's what makes the drawing happen. So when the mouse moves, we're going to run a function called handle mouse move. That's a function I wrote that starts on 58. When the mouse is down, we'll have a function called handle down, which will be run right here. That starts on line 76. Handle up is on line 85. So this is what handles the drawing, and these are called by these events: on mouse move, on mouse up, on mouse down. So the event's happening on the canvas. On mouse move is happening anytime I move. On mouse down happens when I hold the button down. On mouse up when I release the button like I just did. So there's actually actions firing here almost constantly as I move the mouse. You want it to be fast so that the drawing takes place right behind the mouse movement. So you don't want there to be any latency or delay. Okay, so let's now take a look at the next part where here we're just setting the initial style of the line, which is black. The joins between lines will be round and the width will be 5. That's the default unless the user does something else. We've got that 5 width black line. But if I change it, we depart from this. So this sets the default. We hide the save area, and now the application is ready. So all of this code ran when the window loaded to handle all of the events we anticipated. We had to figure out everything the user was going to do, anticipate that, and then write code for it. Okay, so then we've got our delegate functions to handle the mouse move, mouse down, and mouse up events. So on mouse move, I'm logging out client X and Y, the position of the mouse. I was more or less doing that for debugging, but we can take a look and see what that's doing, because we can see anything I'm using console log to log out here in the console. So all those numbers are the X and Y positions of the mouse. We don't need to do this. In fact, it's probably slowing our program down, but while we're debugging, this was useful information for me. So anytime there's a mouse move event, you can see those numbers changing, indicating the position of the mouse on the canvas. Now this next part is important. This line that says, if drawing. You'll remember there's a flag here, this drawing variable. It's initially false. So the rest of this here only happens if drawing is true. How does drawing become true? When the mouse button is down. Here, we essentially now set drawing to the opposite of what it is. So if it's false, drawing becomes true. We do this with drawing equals not drawing. Do another console log for debugging. And now we move the print head, which is what actually draws on the canvas, to where my mouse is, and we begin the path. We begin the line. So every time the mouse goes down, we set drawing to true. We move the print head to where the mouse is, and we begin drawing. So then when drawing is true, we make a line to the next position of the mouse, we close the path, stroke, and then move to where the mouse is. So essentially what's happening here is we move the mouse, we're making a line to each new location, closing the path and stroking it. So we're making here hundreds of tiny little lines that are joining to create the larger line. So as we move, it's lining to the position, closing the path, creating a stroke, which is what makes you see it, and then moving to the next position. And that's exactly what's happening as I draw here, or I should say finger paint. Now, if drawing is false, we move, but we don't draw. We keep moving to whatever position the mouse is. So this way we keep up with the mouse. So now drawing is false, there's no line. As soon as the mouse button goes down, drawing is true, and we're going through that line to close path stroke series again. Mouse up, that stops. That's a pretty good drawing. All right, then finally here we handle up, which reverses the drawing flag, and again we're console logging out whether or not we're drawing. And that's really it. So we have a fairly simple application here that is event driven. It responds to a change in color. It responds to a change in width. It responds to a click in the Save button, a click on the Back button, and a click on the Clear button. And it responds to mouse movement, mouse down, and mouse up. So there you have it, the classic finger paint program. I hope you enjoyed coding it along with me. This is a great app to learn exactly how drawing on the canvas works and also how to track mouse movements in the application. It's a perfect app to build as you're learning JavaScript once you've got the basic syntax down. Thanks so much for watching. I'm Mark Lassoff. Don't forget, if you enjoyed this video, I'd really appreciate you hitting the like button, subscribing to our channel, and leaving a comment. Have a great day, and thanks again.